Alright everyone, welcome back to chapter 11.5. We're going to deal with area of a circle and sectors. Now, most of you have probably already done area of a circle, so this part of it will be a review, and then we'll talk about what is a sector and how do we find the area of it. So, first of all, let's start off by defining what a sector is, and then we'll use it a little later in the lesson. A sector of a circle is the region bounded by two radii of the circle and their intercepted arcs. So over here I have drawn a circle, and I have drawn my two radius or my radii by the green portion, and then the part that is called the sector would be my orange shaded area. So when we're talking about the sector or the area of a sector, you're talking about what is in between those two radii. Going down a little bit further to some information we already might know, Theorem 11.9, the area of a circle. And again, you have to remember we are looking at area now. So what is the inside of your figure? And the area of a circle is pi times the square of the radius. So I have already wrote out the equation in terms of variables. And remember that in our circumference, we had two different equations, and as you can see, we're only going to deal with one equation. So if you're given the dimensions of the diameter, just take a half of your diameter so you can get your radius that you need to plug into your equation. Some people might forget or get the circumference and area equations mixed up. Just remember that in your area, you're always dealing with units squared. So I try to remember that squared and squared will always be used within the same problem. So that's kind of how I remember the equations or differentiate the equations. So going down to use this equation, we are asked to find the area of our circle in A. And we have our radius as 4.2. And remember, our radius is half the distance across the circle, starting from the center point. So our radius they give us, so let's just plug it into our equation. Remember, the area of a circle equation is pi r squared. So we're just going to plug it in, fill it in the blank. So pi times 4.2 squared. So you would get 17.64 pi, and remember that is in terms of pi, and if we want an approximate answer, we would get 55.42. And remember to use that pi button on your calculator instead of rounding from the beginning. Alright, let's try to find our diameter in B. So they give us the area, but we're still going to use the area equals pi r squared because area of a circle, and we're going to use that squared equation. So we wrote the formula, and now we have to plug it in for A because we have our area. And remember how you solve these equations. I'll do it out to the side so we can see all the steps. I'm going to divide both sides by pi because I need my pi's to cancel. They're on the right hand side. So I'd be left with r squared equals 201 divided by pi. That would be in terms of pi. And then my radius, because I'm solving for r in this equation, would be 8. But they have asked me, I need to look back at what they have asked me to find, which is your diameter. So my radius is 8 inches. So my diameter then would be 2 times my radius, which would give me 16. Alright, well, what if, an extra example, they give us my diameter and I'm asked to find the area? The only step that you need to do, other than what you did in A, is just divide your diameter by 2 to give you your radius of 20. And then go ahead and write it in your area of a circle equation. So you'd have area equals pi times 20 squared, and then your final answer would be approximately 1256.6 units squared. So moving on, I have a little problem up here before we get into sectors. So I have 3 circles, 1 big circle, and then 2 circles that fill up the big circle. Now I want to find the area of the shaded version. Well, I first have to find the area of the unshaded circle. So I'm just going to use my same equation. Area equals pi r squared. I know my radius is 3. So I'm going to say my area equals pi times 3 squared. So my area of 1 circle would be approximately 28.27, and I have 2 of those, so I'm going to times it by 2. So I would get 56.55 meters squared for both of my unshaded. Now I want to find my whole blue circle. Well, I know that the 2 circles intersect at the center, and I know my radius is 3, but my diameter is 6. So I can use 6 as my radius of my big circle to find my area. So I get area equals pi times 6 squared. So my area would approximately be 113.10. And then I'm going to just subtract the 2. So 113.10 minus 56.55 gives me approximately 56.55 meters squared for the shaded region. Alright, so we're going to go down to 10 or 11.10, the area of a sector. Remember, that's the area that's bounded between 2 radii. So the ratio of the area of a sector of a circle to the area of the whole circle, which is your pi r squared, is equal to the ratio of the measure of the intercepted arcs to 360. So we're going to use half of what we used yesterday and put it into our equation. If you notice, the 2 that are created that pretty much say the same thing. So I'm going to put my area of my sector, which would be my orange shaded part, that is the area, over my whole area equals the measure of my arc over 360. I can also write it like it is below, or I have also written it in terms of my angle. Remember, my central angle is the same as my arc length, so I can use it in both ways. Moving down to our first example, we want to find the areas of the sector formed by our angle. So again, there are 2 sectors. There is our small one, and then there is also our large sector that goes the other way around the circle. So I first need to find out each arc measure. So my angle RQS equals 63 degrees. So my measure of my green arc would be also 63 degrees because of what we learned in the last chapter. But how do I find my other arc? Well, my whole circle is 360 minus the part that I already have for RS. So that would give me 297 degrees. I guess I can fill it in over here. Alright, so I have those 2 things that I need before I start my equations. So I need to find the area of the small sector, and I've gone ahead and redrawn the sector that we're working with. And again, my equation, my area of my small sector equals the measure of the arc RS over 360 times my area. So my arc, we said, was 63 over 360 times pi, and my radius they give us is 5 squared. So I can do that out in my calculator, and I would approximately get 13.74. And remember that this part is your area all the time. Alright, so next I'm going to move on to my larger sector, and my larger arc would be RPS. So I found that to be 297 degrees over 360 times my area, which would be pi times 5 squared. After I did that in my calculator, I'd come out with approximately 64.80. So the areas of the small and large sector are about 13.74 square units and 64.80 square units. So if you need to stop that or replay it, go ahead and do so. Otherwise, you can go ahead and do your checkpoints 1, 2, and 3. And then if you have any questions, please ask me when you see me. But go ahead and pause it and then check your answers. Alright, we're going to go ahead and go on to finding the area of the sector. So we're going to kind of be in reverse. Remember our equation. Area of a sector equals the arc measure over 360 times my area. So this is what I'm solving for now. Instead of having pi r squared there, I'm just going to have my area. So my area of my sector is told to me by 22 meters squared. My arc length, I know, is also 45 since my central angle is there. I'm going to simplify this part of my equation. So I would get 22 equals 1/8 of my area. How do I get rid of that? I'm going to multiply both sides by 8/1, my reciprocal. So 22 times 8 would give me 176 meters squared. Alright, continuing with this, y'all are doing really good. My last thing, I need to find the area. I have a constructor or a contractor that needs to cut a section of a rectangular piece of wood as shown. To the nearest square inch, what is the area of wood remaining? So what area, after he cuts this piece of wood out, am I going to get back? So the area you need to find is the area of the rectangle. So the whole rectangle minus this little piece on the inside. So if I created that piece, I would get a rectangle. The cutout can be divided into a semicircle, which is at the bottom here, and then a square, since I know that my base is a square and my height is a square. So the area of a rectangle we can easily find by base times height, right? So I would say 11 times 7, which would give me 77. And I'm going to subtract the area of my semicircle. So my sector of my circle that I need to find is 180 degrees, and I'm going to put that over 360 using that equation times the area of my circle. Well, I know from that my radius would be half of 3, so my radius equals 1.5. So I'm going to plug that into my equation. So pi times 1.5 squared, and I would get approximately 3.53429. And then I'm going to find the area of my square. And I know my area of my square is 3 squared, or side squared. So that would be 9. So I'm going to finish that equation, and I would say this is going to be approximately 64.47 square inches, what will be left when I have cut out my piece. Alright, so we are done, crazy enough, with our lesson. So go ahead and do 4 and 5, practice on your sectors in the area of your sector, and then you can check your work with mine. Hope you enjoyed the lesson, and look forward to seeing you in class. Have a great night.